Hello there again. For those of you who couldn't read the title on your own, firstly, thanks for clicking on the video anyway, and secondly, today we're deep diving into Camelopardalis. And yes, I'm gonna say it like that because I didn't do 10 years of Latin to read Latin words like English ones. Normally this part of the video is where I explain the mythology behind the constellation, but unfortunately Camelopardalis doesn't actually have much of a backstory. It just looks a bit like a giraffe, so some Greek guy decided to call it giraffe. So I'll make up for it with a fun fact. The Greek word for giraffe literally means camel leopard, which is also exactly how I'd describe a giraffe to someone who's never seen one. Moving on, presenting on Camelopardalis and a number of other northern constellations comes with a bit of a problem for me. You see, I live in the southern hemisphere, so I've never actually seen Camelopardalis in person. As such, I can't really give much advice on how to find it. It is, however, very near Cassiopeia and Ursa Minor, which are both known for being highly recognizable, as well as Capella, which is the 6th brightest star in the night sky. All of the stars in Camelopardalis are quite faint though, so it might take you a while to get used to finding them. But once you are used to it, Camelopardalis has a lot to offer in terms of interesting galaxies, since it points right into deep space. Let's start with NGC 2403, or Caldwell 7, a spiral galaxy 8 million light years away, located in the space between Camelopardalis and Ursa Major. Caldwell 7 is basically the Triangulum galaxy's long-lost twin. Triangulum is 60,000 light years across, and Caldwell 7 is 50,000 light years across. Triangulum is littered with star-forming H2 regions, and so is Caldwell 7. Triangulum has a massive 1,500 light-year wide H2 region on its outer edge, and Caldwell has a 2,000 light-year wide one in the same place. Not to mention that they just look eerily similar. Aside from that, Caldwell 7 was also the first galaxy cluster outside of our own local cluster, it's in the M81 group, to be discovered to have Cepheid variable stars. And by none other than Edwin Hubble. But it also serves to prove that even the best of us make mistakes, as Hubble calculated Caldwell 7 to be about 1,000 times further away than it actually is. Next up is Caldwell 7's neighbour NGC 2366. It's right nearby Caldwell 7 in the sky, and it's only 10 million light years away, so it's one of those cases where things in the night sky that look close actually kind of are for once. NGC 2366 is noteworthy for having many large blue stars. And I know what some of you might be thinking, but spectral analysis shows that they are not actually Wolf-Raynet stars. Well, except for maybe 8 or so in one specific area. But these stars might make NGC 2366 a good analogy for green Pea Galaxies. A green Pea Galaxy is a special kind of galaxy only found in the furthest distances of the universe. And we have to remember two things about things that are far away in space. One, it's harder to see any detail in them because they look really small because they're far away. And two, they are very, very old. But we're not interested in green Pea Galaxies just because they're old and bluer than the average galaxy. They might have been responsible in part for the formation of the universe. You see, in the present, hydrogen atoms are, for the most part, ionized. But when the universe was originally cooled down enough for hydrogen atoms to actually form, they would have been unionized. And since most green Pea Galaxies are emitters of Lyman alpha radiation, they've made the shortlist for potential suspects responsible for this ionization. And since NGC 2366 appears to be similar in structure to these green peas, we may be able to study it to learn more about them instead of building insanely powerful telescopes to study green peas directly. Next up we have another Caldwell galaxy, Caldwell 5, aka IC342, aka the Hidden Galaxy, and it's earned that last title. It's just under 11 million light years away in the IC342 group, and it sits roughly on the line between BE and Gamma Camelopardalis. As you might have guessed from the name IC342 group, it's the brightest in its group. Despite that, and being so close to Earth, it wasn't discovered until 1895. Actually, it should be the third brightest galaxy in the night sky, and at least half the size of a full moon, but it's obscured by dust in the Milky Way. But it is still visible with binoculars, or a telescope if you want to check it out. For our next galaxy, we're taking a big jump out to 173 million light years away. This galaxy is also the most significant member of its own group, the NGC 1961 group, which is all well and good, but not enough to make it into one of my videos. NGC 1961 is by far the most mysterious deep space object I've come across so far. As you can see, one of the arms of NGC 1961 is heavily distorted. Typically when this happens, there's another galaxy pulling the arm out of shape, but there's no obvious culprit pulling NGC 1961. If anything, the larger galaxies in its group are on the opposite side. Failing that, this also happens when two galaxies merge, but NGC 1961 only has one core, so that seems incredibly unlikely. To make matters more confusing, the distorted arm has an arch of X-rays stretched across it. So, in conclusion, nobody knows what the fuck is going on with NGC 1961. But if we're lucky, somebody will figure it out in the next couple of decades. Maybe. And with that, we come to our last and furthest away galaxy. MAC SO 647-JD, I'm assuming that's how it's read at least, is 13 billion light years away. That's billion with a B. And again, since distance equals time, it's estimated that 647-JD, for short, formed 427 million years ago. It's also the second furthest away known object in the universe. Unfortunately, that means we also know very little about it since, as you can see for yourself, it makes up little more than a few pixels. And that brings us to the end of this video. I know this video was a bit shorter than the previous ones, but constellations that point out into deep space typically have fewer things that we can actually see from Earth because there's less Milky Way between us and the things that are in deep space. So next week we'll be making up for it by exploring Virgo, home to the Virgo supercluster and an absolute cornucopia of deep space objects. In the meantime, as usual, you can head over to my Twitter if you want to see more content. And with that, I'll be seeing you in a couple of weeks with my next video.